The European Space Agency releases images that shouldn't exist. Something impossible surrounds interstellar comet 3I Atlas, a perfect spherical halo 50,000 kilometers wide, burning with the power of 10,000 suns where there should be nothing but frozen rock and ice. This isn't how comets work. Where normal comas fade like smoke, this thing cuts off sharp as glass. The structure pulses with petawatts of energy from nowhere, maintaining geometric perfection that nature doesn't build. In 2 weeks, it vanishes behind the sun, and we lose our only chance to understand it. Is this unknown physics announcing itself? Or is something using our solar system for purposes we can't even imagine? Solar Orbiter wasn't even looking for the comet when it found the anomaly. The spacecraft was conducting routine coronal observations, mapping solar wind streams ahead of a predicted coronal mass ejection. The interstellar visitor happened to drift through the instrument's field of view during a long exposure sequence designed to capture faint plasma structures around the sun. Dr. Sarah Chen from ESA's processing team noticed it first during calibration checks 3 days later. A bright, symmetric ring appeared in frame 047, centered on what should have been empty space. Cross-referencing confirmed it. 3I Atlas, exactly where the ephemeris predicted, but surrounded by something that shouldn't exist. The object sat 187 million kilometers from solar orbiter, yet the halo structure showed crisp definition even at that distance. The team immediately requested emergency observation time. Over the next 72 hours, 6 different instruments captured the phenomenon across the electromagnetic spectrum. Every single observation showed the same impossible structure, a geometrically perfect shell of energy surrounding an object that should barely be active at this distance from the sun. The discovery triggered immediate alerts to every major space agency. Within hours, telescopes and spacecraft across the solar system were reorienting, abandoning scheduled observations to focus on one target. What they found would challenge everything we thought we knew about interstellar visitors. But first, someone had to measure the impossible. The measurements tell a story that physics can't quite explain. The halo maintains near-perfect spherical geometry, more circular than most planetary orbits. Its outer boundary sits at exactly 47,000 kilometers from the nucleus, varying by less than 500 kilometers across its entire circumference. But it's the internal structure that really breaks the models. The emission intensity follows a stepped profile that no natural process should create. Constant brightness from the nucleus out to 31,000 kilometers, then a sharp jump, a 40% increase that holds steady to the outer edge. Like someone drew boundaries in space and filled them with light. Spectroscopic analysis reveals the impossible. Strong oxygen emissions indicating temperatures exceeding 100,000 Kelvin. Yet simultaneously molecular bands from CO2 and complex carbon chains that would instantly dissociate at such temperatures. The infrared signature suggests organized outflow velocities of over 2,000 meters per second, all perfectly radial from the center. The total energy output reaches petawatts in the observed bands alone. For comparison, comet Hale-Bopp at its peak released about 1% of that. The power density peaks in narrow wavelength bands rather than the broad thermal spectrum expected from heated gas. The polarization measurements add another layer to the mystery. The light is linearly polarized in a radial pattern centered on the nucleus, suggesting organized field structures rather than random scattering. Standard comet models can't even come close to explaining this. We're looking at something that operates by different rules entirely. Confirmation came swiftly from unexpected sources across the solar system. NASA's Parker Solar Probe, swinging through its perihelion just 7 million kilometers from the sun, detected anomalous radio emissions at 42 megahertz. The signals appeared whenever 3I Atlas rose above Parker's horizon, showing frequency drift patterns consistent with electrons spiraling through magnetic fields 3 times stronger than typical interplanetary fields at that distance. SOHO's LASCO C3 coronagraph caught the object during its October 28 observations. The white light images revealed something the other instruments missed entirely, a double shell structure, the main halo at 47,000 kilometers plus a fainter outer envelope reaching past 70,000 kilometers. This outer layer pulsates with a 14.7-hour period, brightening and dimming by nearly a third in perfect rhythm. Even ground-based observatories managed to contribute despite the solar proximity. The Atacama Large Millimeter Array detected emissions suggesting dust temperatures far hotter than equilibrium temperatures at that distance from the sun. The dust appears confined within the halo boundary rather than streaming away in a tail. Japan's Subaru telescope captured near-infrared images showing the halo maintains its structure even in reflected sunlight. The consistency across every part of the electromagnetic spectrum argues against instrumental artifacts or processing errors. Multiple instruments, multiple wavelengths, multiple nations, all seeing the same thing. This is real, repeatable, and defying every attempt at conventional explanation. So the theorists scrambled for answers, any answers that could make sense of it. The mainstream explanations came quickly but crumbled just as fast. Plasma physicists proposed exotic charge exchange reactions between solar wind and cometary neutrals. The mechanism works in theory, creating a standoff boundary where pressures balance. But the numbers don't add up. To maintain a cavity this large against solar wind requires gas densities that would demand mass loss rates exceeding 100,000 kilograms per second. At that rate, even a large nucleus would completely evaporate in weeks. Yet 3I Atlas has maintained steady brightness for months. The magnetic field hypothesis fares no better. Some comets generate weak-induced magnetospheres through photoionization, but this would need field strengths hundreds of times stronger than any comet ever measured. No known mechanism can generate such fields in an icy body. Rocky asteroids barely manage a fraction of what's needed. Ice and dust? Orders of magnitude weaker still. Dr. Martin Holbrook from Max Planck proposed the most creative natural explanation yet: a resonance effect between molecular emissions and solar UV creating runaway fluorescence cascades. His team modeled phase-locked photon absorption and re-emission patterns. The model reproduces some spectral features but requires molecular abundances that simply don't exist in nature. It also can't explain the geometric perfection, the radio emissions, or the stepped brightness profile. Each natural explanation captures fragments of the phenomenon, but none explain the whole. The halo resists every attempt to fit it into known physics. We're left with an uncomfortable possibility. Maybe it doesn't fit because it wasn't meant to. Even before the halo discovery, 3I Atlas was rewriting the comet rulebook. Its hyperbolic trajectory confirms its origin beyond our solar system, approaching from Sagittarius at interstellar velocities. The path is retrograde, moving opposite to everything else in our solar system, like a car driving the wrong way on a cosmic highway. The chemistry alone should have been our first warning. Nickel dominates iron by ratios that don't exist in our solar system. Carbon dioxide outgasses at 5 times the rate of water, completely reversed from normal comets. The cyanogen bands that define classical comets barely register. Instead, complex carbon chains appear in abundances suggesting formation in the deepest voids between stars. Size estimates vary wildly depending on what you assume. Using typical comet reflectivity suggests an 18-kilometer nucleus, but radar observations before Arecibo shut down indicated something much smaller with anomalously high reflectivity. The discrepancy implies either unusual surface composition or geometry that scatters radio waves in ways we don't understand. Then there are the thrust events. 3 discrete velocity changes since discovery, each precisely 0.4 meters per second, always aligned with the rotation axis rather than the sun direction. Standard outgassing produces continuous acceleration. These look like controlled burns, timed at exact 21-day intervals. The pattern was already clear before the halo appeared. The 3I Atlas doesn't behave like a natural object. The halo just made it impossible to ignore. The energy budget breaks physics as we know it. Total electromagnetic output across all wavelengths reaches 3.7 petawatts. Solar radiation hitting an 18-kilometer nucleus at this distance delivers maybe 200 gigawatts. Even perfect energy conversion falls short by 4 orders of magnitude. Sublimation can't bridge the gap. Vaporizing CO2 ice releases specific energy that would require millions of kilograms per second to power the observed emissions. The entire nucleus would vanish in days at that rate. Yet 3I Atlas maintains steady output month after month. The magnetic energy density within the halo volume suggests organized currents of roughly 1 billion amperes. Natural plasmas can't sustain such currents without a continuous driver. Something is actively maintaining these field configurations against dissipation. Particle energies show impossible stratification. Electron temperatures reach millions of degrees based on UV line ratios, hot enough for X-ray emission. Yet dust grains in the same volume maintain temperatures barely above what solar heating provides. This selective heating requires mechanisms that target specific particle populations while ignoring others. One possibility involves resonant wave-particle interactions. Electromagnetic waves at precise frequencies could accelerate electrons while leaving heavier particles unaffected. But generating such waves requires tuned oscillators, not random natural processes. The power source remains a complete mystery. But mystery is relative when you look at what we already knew about this object before the halo ever appeared. The comet archives offer no true parallels. Comet Holmes brightened by a factor of 1 million overnight in 2007, creating a spherical coma that briefly resembled what we're seeing. But Holmes expanded and dissipated over weeks. The 3I Atlas structure holds its boundaries with mechanical precision for months. Comet Hyakutake surprised everyone with X-ray emissions in 1996. It proved comets could produce high-energy photons through solar-wind interactions. Yet Hyakutake's emissions measured in megawatts, not petawatts, and they came from extended regions, not geometric shells. The Great Comet of 1882 split into fragments that maintained parallel paths, showing structural integrity beyond simple dirty snowballs. Some fragments developed independent atmospheres, but these were transient features during the disruption event. Nothing sustained and geometric like this halo. Oumuamua, our first confirmed interstellar visitor, showed acceleration without visible outgassing. That sparked debates about exotic propulsion that continue today, but Oumuamua never developed any visible coma despite passing closer to the Sun. If both objects represent something artificial, they're using fundamentally different approaches. The halo phenomenon stands alone in observational astronomy, a sustained, geometric, high-energy structure that no amount of searching can match in our records. We've seen pieces of this puzzle before, but never assembled into something this coherent and impossible. The window closes fast. 3I Atlas reaches perihelion on October 29th at 1.36 AU, then speeds toward solar conjunction. From November 3rd to 18th, the Sun blocks Earth-based observations entirely. 15 critical days when only spacecraft with favorable positions can track the object. Solar Orbiter maintains the best viewing angle through early November. ESA has cleared its entire observation schedule for continuous monitoring. Every instrument, every sensor, every available resource focused on one target. The spectral imaging instrument should detect changes in extreme UV emissions down to fraction of a percent variations. The radio and plasma waves detector will search for patterns in electromagnetic emissions that might reveal the halo's generation mechanism. Parker Solar Probe swings through perihelion again on November 6th. While too close to image directly, Parker will sample the solar wind disturbed by the comet's passage. Any exotic particles or field configurations swept downstream could provide crucial clues. After conjunction, 3I Atlas emerges into morning skies at magnitude 8.5. Amateur telescopes with moderate apertures can track it, though the halo itself requires specialized filters to detect from Earth. Hydrogen alpha and oxygen 3 filters might reveal traces against dawn twilight. Professional observatories already block out intensive campaigns for late November through December. By January 2026, 3I Atlas will fade beyond easy detection as it races back toward interstellar space. Every observation between now and then matters. We may never see anything like this again. The evidence assembles into a picture that challenges our understanding of both comets and interstellar objects. The halo around 3I Atlas demonstrates organized energy patterns at scales and intensities that natural processes struggle to produce. Its geometric perfection, sustained power output, and multi-wavelength coherence point toward mechanisms we don't understand. The questions multiply faster than answers arrive. What maintains the sharp halo boundary against solar wind pressure? How does the structure generate coordinated emissions across the entire electromagnetic spectrum? Why does the energy output exceed solar input by 10,000 times? What creates the clockwork pulsation in the outer envelope? How do the discrete thrust events connect to the halo phenomenon? The implications stretch beyond one unusual comet. If interstellar objects can generate such structures, our entire detection strategy needs revision. Current surveys look for reflected sunlight or thermal emissions. Active halos could make objects visible at far greater distances, but only if we know what to look for. The Vera Rubin Observatory, beginning operations in 2026, will scan the entire sky every 3 nights. Its sensitivity might catch similar halos around other interstellar visitors before they reach the inner solar system. Understanding 3I Atlas could provide the template for recognizing whatever these objects represent. We're witnessing something that doesn't fit our models. Whether that points to exotic natural phenomena we've never encountered or something else entirely remains an open question. What's certain is that 3I Atlas has revealed our cosmic neighborhood is far stranger than we imagined. The universe just became more mysterious, and we're running out of time to solve this particular mystery before it escapes forever into the dark between the stars.